Hello everyone, this is Keith Jackson and welcome to Jack's Math Notebook. In this video, we're going to compare two-step equations with that of two-step inequalities, their counterparts. And so we have three big examples up top as far as equations are concerned, two-step equations are concerned, and then we're going to have three big examples involving inequalities using the same numbers, but keep in mind we're going to use the same procedure, and I'm going to show you how that's going to work itself out. And so in big example 1a, we have 2 times the quantity of x plus 3 is equal to a negative 12. And what we're going to do, we're just going to distribute this to across the parentheses, just like you see right here. So we have 2 times x plus 2 times 3. 2 times x will give me 2x, while 2 times 3 will give me 6. And we're going to set that equal to a negative 12. All right, and so now what we're going to do, we're going to isolate this variable even further by doing the opposite of addition right here because we have a plus 6. So what we're going to do, we're just going to subtract 6 from both sides. And when we do that, we'll get our classic 0 on this side because we need to get that 0 that is on the same side as the variable right there, just to see right there. And so then what we're going to do, we're just going to go ahead and say, well, a negative 12 plus a negative 6 will give us a negative 18. Now we have this 2x is equal to a negative 18 right here. And all we have to do is just divide both sides by 2 to find out what x is. And when we do that, these 2's cancel themselves out, leaving just x as you see here. And knowing that a negative 18 divided by 2 will give us a negative 9. And so we know that x is equal to a negative 9. All we have to do is just plug in negative 9 back into this equation, and we will arrive at negative 12 as our answer. But let's take a look at its counterpart with big example 1b. And in this case, we have 2 times the quantity of x plus 3 is greater than a negative 12. We do precisely the same operations, okay, getting x on one side, or I should say isolating the variable, which is x. That's what we did here. Notice how we have a minus 6 here, minus 6 here, just like we did with its counterpart equation up here back in big example 1a. So we're doing the same thing, but this time we're just using the greater than symbol right here. We're using the inequality symbol instead of the equal sign. And when we do that, we have 2x is greater than a negative 18. And all we have to do again is just divide both sides by 2. When we do that, we just get an x. And it is greater than, in this case, negative 9. So instead of x is equal to a negative 9, we have x is greater than negative 9. And we can set that on the number line because, see, this inequality symbol tells you which direction x is in comparison to negative 9. And as you can see, x is any number to the right of negative 9. Let's move on to big example 2a, in which we have a negative 3n plus 5 is equal to a negative 16. And what we're going to do, we're going to isolate the variable, right? And so in this case, we have a plus 5. So we're going to do the inverse operation of subtracting 5 from both sides so we can get that 0 because we want that 0 on the same side as the variable, right? And so now we have that 0 here, and a negative 16 plus a negative 5 will give us a negative 21. And now we have a negative 3n is equal to a negative 21. And if we divide both sides by a negative 3, the reason why we're dividing both sides by a negative 3 because it's right next to the letter n, and that will help us isolate that variable. And so when we do that, a negative 3 divided by a negative 3 will give us just one n or n, while a negative 21 divided by a negative 3 will give us a positive 7, because a negative divided by a negative will give us a positive, and that's why n is equal to 7 right here. Now let's take a look at its counterpart in big example 2b, in which we have 3n plus 5 is less than or equal to a negative 16. We perform precisely the same operation. Again, we subtract 5 from both sides, getting that 0 right there. And then we have a negative 16 plus a negative 5 will give us that negative 21. And so all we have right here is that a negative 3n is less than or equal to a negative 21. All right. And so now that we have that, keeping in mind that when we divide by a negative number, we have to switch that inequality sign. Notice how it switched this in this direction right here because we divided both sides by a negative 3, which changes the inequality symbol. And so we have a negative 3 divided by a negative 3, which will give us n, and a negative 21 divided by a negative 3, which will give us a 7. And in this case, n is greater than or equal to 7. All right, and so we have it right here. And notice that we have a shaded circle because we're using the greater than or equal to sign. This lets us know that it could include 7 and it could be greater than 7. That's why this circle is shaded as opposed to right, this circle is open right here over the -9 in big example 1b. That's why we have this shaded circle here, again, because we have greater than or equal to. Now let's move on to big example 3a, which will have 4 plus a divided by 5 is equal to 10. And so what we're going to do, we're going to isolate the variable, which is a, and we're going to do that by doing the opposite of +4 by subtracting 4 from both sides. And so when we get that, we are going to get a over 5 is equal to 6. But of course, we're going to multiply both sides by the denominator, which is 5. So 5 times 5a over 5, which will give us a because the 5's cancel themselves out, while 6 times 5 will give us 30. And that lets us know that a is equal to 30. And when you plug it back in to this equation right here, it will work. And we're going to perform precisely the same operation as it relates to this inequality, in which we have 4 plus a divided by 5 is less than 10. We're going to do the same operation by subtracting 4 from both sides to get a all by itself. So we have a divided by 5 is less than 6. We're going to multiply both sides by the denominator, which is 5. When we do that, these 5's cancel themselves out. And of course, 6 times 5 is 30. So we know that a is greater than 30. And when we put it on the number line, we know that, or I should say a is less than 30. Let me repeat that. A is less than 30. And as you can see, we have this open circle because we have this sign that says a cannot be 30. It can only be less than 30 or to the left of 30. Okay. Yeah, I've been given a lot of information. I wouldn't blame you if you need to pause the video to take a look at things or replay this video as many times you need to gain a deeper understanding of these two concepts. But in the meantime, please comment, share, like, and subscribe to Jack's Math Notebook for more content. Thank you and goodbye.